Before we start this video, I'm assuming you already know what JWT is. If not, you can check the link in the description below for a short video on it. Here's a brief overview of JWT authentication. We have something called an access token that has a short expiration time to lower the risk of getting hijacked and prevent stale data. This is usually sent on every request for validation. We also have something called a refresh token that is longer lived, used once, and allows the user to not have to log in every time the access token expires. Here's the first way to implement access and refresh tokens. Usually, we create this access and refresh token whenever a user logins. We send back the access token in the response body. But as for the refresh token, we store it somewhere secure, in this case, an HTTP only cookie, which just means you can only access the cookie on the server side, not the client, like using JavaScript document.cookie property. Next, we'll talk about how we validate tokens. Note how the access token is sent to the client. Well, we store this token in memory, such as in a private variable or state like in React with the user data. The client will send this access token in the header as a bearer token to our server. Usually, we have a middleware to validate it. As you know, anyone can encrypt and decrypt tokens. So we use something called a token secret that is stored on the server that is used to verify if the token is legit. On top of that, we also check if the token is not expired. Great, so how do we renew our access token if it does expire? Well, this is what the client side will do. If the client gets a 401 response, meaning it's not authorized, it will send a request to our refresh route, and the server will validate the refresh token. If it's legit, then the server will create a new refresh token, store it in a new cookie, and send back the new access token. Then the client will reattempt the original request. To invalidate tokens, clearing the cookies or closing the app is not enough, as the tokens are still valid until they expire. This poses a security risk, so to prevent this, we use something called a blacklist, as shown in the diagram. Whenever someone logs out, we add the refresh and access token to our database. The only changes in our code are wherever we verify our tokens, we also need to check if it's not on our blacklist. If it is, then we reject the request. In the second method of JWT auth, we send both the access and refresh token in an HTTP only cookie. Unlike the first method where we did the validation and renewal of access tokens and refresh tokens separately, we do it together here in the middleware. When the client sends a request to the server, the middleware will check if the access token is valid. If it's valid but expired, instead of returning a 401 unauthorized response like the first JWT method, it will instead check if the refresh token is valid, and if so, then the middleware will create a new access and refresh token and attach them in new cookies. Lastly, we invalidate tokens by storing a copy of the refresh token in the database. Anytime we want to renew our access token, we first check if the refresh token is valid and if it matches the one in the database. Also, when a user signs out, we remove the refresh token from the database so the user has to log in again. Alright, now I'll show how to implement both ways in code. So here's a basic Express app setup and the dependencies I'll be using. Run this command twice in your terminal to create your secrets for the access and refresh token. The secret should be at least 64 characters, which 32 bytes gives us. The first JWT auth method uses bearer token and cookie as we discussed earlier. We set the expiry date of the cookie the same as the refresh token for consistency and to prevent memory consumption. HTTP only to access the cookie on the server side. The path of the cookie is sent only for the refresh route and not on every request to reduce exposing the token. Secure is set to true to only send the cookies over secure channel except localhost. And for same site, we use strict if hosting on the same domain and to prevent cross-site request forgery. Otherwise, we can use none if hosting the server and the client on different domains. For the second method, we send the access token in a cookie like the refresh token, except we remove the path attribute for both tokens since we're sending on every request. Both ways have their pros and cons, the cookies being easier to implement but is weaker against cross-site request forgery, while using bearer token protects against it but suffers against cross-site scripting. Here we are implementing the validation in our middleware. We are getting the access token from the header and checking if the token is valid and not expired. If either condition fails, it throws an error. In the second version, we are doing the same thing except we are getting the access token from the cookie. For the first method of refreshing our tokens, we check if it is valid, the refresh token, then send the new access token and the new refresh token accordingly. So this is the first version of how we implement refresh tokens, as you can see in the code here on the left side. In the second version, on the right side, remember that we don't have a refresh route. Instead, we are validating our access token and renewing it if it's expired in one go in our middleware. So here's the final implementation of refreshing our token, one done in the refresh route and the other done in our middleware. Both have their pros and cons. The first way has better performance, but the user experience is slower, whereas the second way is the opposite. Remember, we are using our middleware to validate our access token, so that's why we're not doing it in this route. But it's a good practice to always validate. And as you can see, we're validating your tokens by storing it in the Redis database with the same expiration date as the tokens. I put common blocks to show the changes that need to be made for the listed routes like the refresh and protect and sign out route. For the second version, we are deleting the refresh token associated with the user's email, and the green comment block shows the changes we would need to add for the refresh, protected, and login route. Both methods have their pros. The first way allows a user session per device, while the other is more memory efficient. This is JWT auth 300 seconds. Thanks for watching.